Let's do the first experiment. Task 1, valve characterization. Firstly, we should open the hand valve. We should open cold water and air supply. Also, based on the procedure of the lab, we should close the long valve. So I'm going to close the long valve. 90 degree is to be considered as closed, fully closed, and 0 degrees fully open. And for short valve, it should be fully open, 0 degrees fully open. So short valve should be fully open. Then we use the body operate to operate our experiments. We use this icon if I see 104, which is the cold water flow valve. So if you open it, here the blue one is the valve position. You can change it and see how much is the flow rate of cold water. First we start with the flow valve closed at 0%. So we put 0 here and record the flow rates of cold water, which is 0. Also, we should check that it would be on manual type. So when we increase the valve position by 10%, we should allow the flow to reach steady states. So the steady state value of flow rate is 0.4. So we should record this new value position 10% and this new flow rate. Then we increase this valve position to 20, and again let's the flow to reach out to steady states 2.2. So then we record this new value, and so on. We continue to 10% by 10% to 100% valve position. Once the valve is fully open 100%, after recording the steady state of flow rate, we should decrease the valve position in a reverse way. So I decrease it to 90%. Then we record the new value of flow rate. Also 10%, decrease 10%, so we consider 80% valve position, and we wait to see the steady state of flow rate of cold water. Please pay attention here, we do not decrease the valve position directly to the 0 from 100% to 0. We should decrease the valve position 10% by 10%. So finally we have 0% valve position and the flow rate is 0. So we record the data and we have a data, the flow rate of cold water based on the different percentage of valve position in the increasing way and in the decreasing way, and we can compare the flow rate in the increasing and in the decreasing way. Okay, so as you saw, we increased the valve position from 0% to 100%, and we recorded the flow rate in a forward way. Then we decreased the valve position from 100% to 0%, and again we recorded the data in the reverse way. So after completing all these steps, now you have the collected data, and you can answer to the question 1 and plot the flow rate based on the percentage of valve position in the forward way and reverse way. So now we can discuss about the features of the valve, like nonlinear behavior or anything else, and you should explain what the graph shows. Okay, let's do the task 2, level calibration. For the level calibration, we should first close the short hand valve. So I'm going to close it. And for the long hand valve, we should open the long hand valve to 45 degree. So I open the line and valve to 45 degrees. Okay, let's back to the delta V operate. LIC 101 is level controller. Let me zoom in. Firstly, we should place manual, and the output should be 0 here. And for flow rate of cold water controller, this one here could be on cascade mode. So we change the manual mode to cascade mode. Now the output of this controller, which is the flow rate of cooling water, is related to the level of the liquid in the tank. So we place the level controller on auto. Now if I change the set point, then the input of this controller is changed automatically such that the output reach out to the set point. Okay, then we set the level controller set point here to 0.05. Then as we see, the controller changed the input, which is the flow rate of cooling water, such that the output, the measured value, reach out to the set point. Okay, when the indicated level reaches to the set point 0.05 meter, then we should measure the actual level with a ruler here. So use tape measuring to measure the actual level here. So it's approximately 0.049 meter. So then we should record the display level 0.05 that we are seeing here as the display level, and the measured level that we measure it as the actual level in the table for question 2. So in the next step, we increase the set point of the level from 0.05 meter to 0.3 meter. So I increase the set point of the level in the tank, and again we wait such that the controller reaches to the set points. Okay, again when the indicated level water reach out to the set point 0.3 meter, we can measure the actual level in the tank and record the actual measurement and indicated value. So as you saw, we increased the level set point from 0.05 meter to 0.3 meter in 0.005 increments. Then we recorded the actual water level and displayed level. Now you have the collected data. If it was the perfect sensor, the displayed level and the measured level should be the same, but here there are some differences. So here you should plot the displayed level based on the measured level, and if you connect the points by a line, you should be able to find the equation of the line and then use it to do calibration analysis. Okay, as a last step, in order to shut down the equipment, we should set all the controllers in manual and 0 inputs for all of them. Then we should close the Delta V system and shut down the computer, and also we should close all the valve streams.